Hello everybody. Today I will explain what is known as time value of money. I would like to begin by asking you a question. If I were to offer you 10,000 rupees and I am giving you a choice that you can take it today or you can take it at the end of 1 year, which one will you accept? Obviously your answer is going to be today. And some of the reasons that you may have in mind for this is that it is more valuable to have it today because who knows what is going to happen in the future. Future is uncertain. I may give you, I may not give you. And of course you will say, I prefer current consumption. I would like to have the money today so that I can spend it. Other argument could be that at the end of 1 year, because of inflation, the purchasing power will decrease, and so therefore the value of money will not be same as what it can buy today. And finally you can say that I can put it in the bank to earn interest. So it's like this, if you have 100 rupees and you put it in the bank and the bank gives you an interest at the rate of 6%, after 1 year it is going to become 106. Reverse, if you take 106 rupees a year from now is actually equivalent to 100 rupees. So this point highlights that there is a time value of money. I will now go on to details to explain how we understand and calculate what is known as a future value and present value. You must have studied simple interest and compound interest in your schools, alright. So there you have a principal amount which I will refer to as X. X is the principal amount, K is the rate of interest that is going to be charged, and N is the number of years. So let us understand this. Beginning of the year 1, if I have an amount, principal amount as X, and I am given a rate of interest as K%, the interest amount that I will earn is X multiplied by K, and the total at the end of the year is going to be X into 1 plus K. Now you know your compound interest. For compound interest, this value is going to become the principal at the beginning of the next year. So for year 2, your principal amount is X into 1 plus K, and you will earn an interest of K% on this. So this is your interest amount. Therefore, at the end of the year, you have a value called X into 1 plus K whole square. So for third year, this is going to become the principal amount X into 1 plus K whole square. You will earn an interest on this, and the total at the end of the year is going to be X into 1 plus K raised to the power 3. So if I have to generalize this, for the nth year, principal amount is going to be X into 1 plus K raised to the power n minus 1. This will earn an interest, and finally it is X into 1 plus K raised to the power n. You can see this value X at the beginning of the first year became X into 1 plus K raised to the power n at the end of n years. This is X is referred to as present value because it is happening today, and X into 1 plus K raised to the power n is referred to as future value, because it is happening at the end of n years. So in other words, we can say that future value is equal to x into 1 plus k raised to the power n, and this x we have denoted as present value. This 1 plus k raised to the power n, we are referring to it as future value interest factor at k% and n years. We will understand what this is in a short while from now. Here you can see that it was a one-time investment x, which was compounded for n years, and then we got a value which is known as the future value. So therefore, this is a case of one-time investment. You can have a case where you are investing x amount every year and for n number of years. So this is referred to as an annuity, and in such case this will be future value after n years is going to be x multiplied by future value interest factor of an annuity at k% n years. So this formula is going to be used only when it is a case of annuity, that is equal amount paid out every year. And for finding out this FVIFA or FVIF, there are tables which are available. The formula which we have just understood, if I reverse it, I can calculate the present value. So my present value is the future value multiplied by 1 divided by 1 plus k, the whole raised to the power n. And this I will write as future value n multiplied by present value interest factor at k% and n years. So this is again a one-time investment or one-time flow which is going to happen in the nth year, and I will multiply it by present value interest factor so that I understand what is the value today. So this is also a one-time for calculating your present value. If it is a case of annuity, you will have a formula, similar formula, where you will use the annuity table. So therefore you will multiply it by the present value interest factor of annuity at k% n years. This table is to be used only when it is a case of annuity. I will now show you how these tables look like, future value table and present value tables. So here are the tables. As you can see, this is future value interest factor table. Then we have the next one. It is future value interest factor for an annuity. The third one is present value interest factor, and the fourth is present value interest factor for an annuity. Each of these tables have two dimensions. As you can see, this is the number of years that we are talking of, and this is the interest rate that we are talking of. So if I say 5% 3 years, all you have to do is hunt for the coordinate. So this is 5% and this is 3 years. So wherever you get the coordinate, that is going to be your value that you will use. Let's work out a few examples. So here I am telling you that an amount of 2,500 is given to us to be invested for a period of 5 years, and I will earn an interest rate of 6% on that. So my question is, what is going to be the value at the end of 5 years? Therefore, in order to calculate the future value, I will take the present value, which is 2500, and I will multiply it by the FVIF at 6% 5 years. From the table, I will get a value of 1.338. So if I multiply with 2500, my answer is 3345. So which means that if you save an amount of 2500 for a period of 5 years and you earn a rate of 6% interest, at the end of 5 years it will become 3345. I will now show you how I got this value 1.338 from the tables. So we wanted the value at 6% and 5 years, and it is FVIF because it is a one-time investment. Let's hunt for the coordinate. This is 6% and this is 5 years. So I arrive at this number 1.338. This is how we use the future value and present value tables. Let's look at the second example. So we have an amount of 1500, but it is going to be invested every year. Same amount every year. This is the case of annuity. Time is 8 years, interest is 4%, and I need to find out what is going to be the future value at the end of 8 years. So I will take 1500 and I multiply it by FVIFA. This is the second table, FVIFA. It's an annuity table at 4% and 8 years. The value, corresponding value is 9.214. So when I multiply it, I get 13,821. If you would have just multiplied 1500 with 8, your answer would have been 1200. But because this is a case where the interest is being compounded, your value becomes 13,821. Let us look at the third example. Now we are going to calculate present value. So you are told that you will receive an amount of 20,000 at the end of 5 years. All right? And when we are doing present value, we use the word discount rate instead of interest rate. All right? So discount rate is given as 4%. And you are supposed to find out what is the present value today. So what you need to do is take this 20,000, and because it is a one-time amount, I will multiply it by the present value interest factor at 4% 5 years. So from the table, the corresponding figure is 0.822, and if you multiply that by 20,000, your answer comes to 16,440. So which means an amount of 20,000 5 years from now is actually worth 16,440 if the discount rate is 4%. This is the last example. If you are to receive an amount of 1,000 coming in every year, all right, at the end of year 1, year 2, like that for a period of 6 years, and the discount rate is 3%, you are to calculate what is the present value today. So this is a case of annuity, and we will look up the annuity table. We will take the present value interest factor of an annuity at 3% and 6 years, and the figure comes to 5.417. So if you multiply that by 1000, it works out to 5417. If you would not have used this time value of money concept, you would have said that I am going to receive 6,000 because it was 1,000 coming in for 6 years. But the moment you take the time value of money, you understand that it is actually worth 5,417 as of today. We need to understand two concepts, beginning of the year and end of a year. If you look at this point, this is end of year 1 but beginning of year 2, alright. And similarly, if I take this, it is the end of 3rd year but beginning of the 4th year. And at what point of time you make the investment has an impact on the value. In this case, we are supposed to save 1000 every year for a period of 5 years, alright. And if you decide to put in the money at the end of a year, how will it look like? So, end of the 1st year you put in 1000, end of 2nd year another one, like that till the last year, and you put it at the last day of the last year. So, if you want to calculate the future value, obviously this last installment will not earn you anything because you have put in on the last day of the year. The installment of your 4th year is going to earn you interest for a period of 1 year. So, therefore, FVIF 4% 1 year. The one which you put in the 3rd year is going to earn you interest for 2 years. Therefore, FVIF 4% 2 years. This one is going to earn for a period of 3 years. So, FVIF 4% 3 years, and the first installment is going to earn you for a period of 4 years. Therefore, we will multiply by FVIF 4% 4 years. Okay. So, in this manner, if you calculate the future value, your answer will come out to 5417. This 1000 multiplied by 1.170 is for the first installment. Then 1000 multiplied by 1.125, this is for the second installment. Can you see for the last one? For this last one I have multiplied by 1 because it is not earning any interest. The value will remain as it is, alright. So, in this way you arrive at an answer of 5417. We will now see what happens if you would have started making the payment from the beginning of the year instead of end of a year. This I will show you now. Now, if you had put in your amount from the beginning of the year, you can see year 0, that is the start of year 1. There is a 1000 which is happening, and it goes on. There are 5 installments, and the last installment is taking place in the 4th year, alright, and end of 4th year or the beginning of 5th year. So, therefore, the difference here is that this installment of the last installment will earn you for 1 year, and this first installment will earn you for a period of 5 years. This is the difference with the previous one. So, therefore, if I do the future value calculations, this time my answer works out to 5634, which is higher than the previous one, and only because we had made the investments in the beginning of the year and not the end of the year. We had discussed about annuity, no? It is that same amount which happens every year. Now, if this happens like for an infinite period of time, forever, then it is referred to as perpetuity. And to find out the present value of a perpetuity, this is the formula you will use. The constant annual amount divided by the interest rate. So, if your amount is say 500, this is 500 divided by the interest rate. If interest rate is say 4%, 0.04, then this will become the value of the perpetuity. Sometimes there is a case that it is a perpetuity, it will go on forever, and it's a constant amount also, but that constant amount will grow by a certain growth rate. Then your formula is a little different. In the numerator you will have the constant annual amount, but in the denominator it is going to be interest rate minus the growth rate. So, if it is the same example and I say that there is a growth rate of 10%, So my formula will be 500 is the constant annual amount. Interest rate was 4% and 1% is the growth rate. So then it's going to be this formula. So this is how you will calculate the present value of a perpetuity. So far we have been using compounding, but it was an compounding, annual compounding, once a year, all right. You can have compounding multiple times a year. There are some deposits which offer you a compounding twice a year, maybe 4 times a year also. So what happens in that case? Let us take an example. Suppose the interest is 10% and the time is given 5 years, all right, and it is going to be compounded twice a year. Our formula for that is future value is going to be the present value multiplied by 1 plus k divided by m. K is the interest, m is the number of times it is compounded, all right, and this is raised to the power m into n. So in our example, present value, suppose it is 100, I will multiply it by 1 plus 10% divided by 2 and raised to the power 2 into 5. So this is a case of 100 multiplied by future value interest factor at 5% 10 years. So if you take the value from the table, it is 1.629 and it becomes 162.9. Can you see the difference? If I would have taken 100 rupees and just use the regular compounding, all right, I would have earned only 10%. But in this case, you can see that this 100 rupees has become a higher value, all right. So therefore, the effective rate of interest is different out here. This brings you that you understand now 2 new words. One is this rate which is stated, all right. This is the stated rate, and what you actually get is known as the effective rate. And obviously your effective rate is always greater than the stated rate because you are compounding it multiple times a year. So with this, I conclude the session on time value of money. In further sessions, we will work out more examples for your understanding. Thank you very much.